I was able to explain that matter can exist as solid, liquid, and gases, and substances or matter can change from solid directly to gases without passing through the liquid state. This is called sublimation. And substances can change from gases directly to solid without passing through the liquid state. This is called deposition. Example of deposition is water vapor in air. Water vapor under a very low temperature can change to ice directly. This is why in cold region, you look at your window, you see block, it appears. So not liquid or water coming first before changing to block. That is deposition. Hello, I am Flash Isaac, and today I shall be solving likely chemistry questions in Jamb. This is part 1 of the video. I shall be writing out the questions and using the opportunity to treat the topics. So make sure you pay attention, make sure you follow, because this class is going to help you score very high in Jamb chemistry. Don't forget, this is the part 1. Part 2 will be out soon. And I've also covered likely Jamb questions under other subjects, so you can check those out in the channel. Subscribe because it's going to be fun for you. Let's look at this question. It says the change of state of a substance from solid to liquid is known as the change of state of a substance. Now, substances can be elements, compound, or mixture. How about we talk about chemistry? Chemistry is the study of the composition, properties, and uses of matter. The study of the composition, properties, and uses of matter. Matter is anything that has mass and occupies space. Mass and occupies space. Mass is different from weight. Look at weight. While mass is the quantity of matter a body possesses, weight is the earth pull on a body. This means you can't experience the weight of a body until it is raised up. So, as this is staying here, it has its own mass. But due to gravity, which is a force that brings all objects to the ground, the body begins to have weight. So if we have a body of mass, let's say 2 kilograms on Earth, with gravity, let's say 10 meter per second square g, or 9.8 meter per second square. In calculations, you'll be given values to use. But when you are not given, assume 9.8 meter per second square. And weight is equals mg. This means once the mass of a body is multiplied by the acceleration due to gravity, it begins to have weight. So this is weight. The weight of a body of mass 2 kg is simply 2 times 10. That is 20 Newton if we are using 10. So weight is the earth pull on the body. So the weight of things on earth is different from the weight of things in the moon, because the gravity in the moon is different from gravity on earth. And when there is no gravity, anything that goes up continues that way. Gravity is that force that brings objects down. So we've been able to explain that matter is anything that has mass and occupies space. And I also explained that mass is the quantity of matter a body possesses. And it is different from weight in the sense that weight is the earth pull on a body. Mass times acceleration due to gravity gives us weight. And the unit of weight is Newton. This is also the unit of force. Look at this. Chemistry is the study of the composition, properties, and uses of matter. Composition means, what is this matter made of? What is matter made up of? So this is a matter, air is matter, this is a matter, I am matter. So almost everything in the universe are matter. So anything you see around, you can even mention they are matter. What are the properties of this matter? So what are matter? What is it used for? These are the things chemistry studies. There is something you should note about matter or about substance. Matter can exist in different forms, in solid, liquid, and gaseous state. So this we call them states of matter. States. In liquid, the force of attraction between the body is compact. There is a force between them, holding them. This is the reason solid have definite shape. This is a solid. This is a solid. The marker board is a solid. Blocks, these are solid. Solid state of matter. While in liquid, the force between the molecules, the force of attraction between the molecules is not as strong as that of solid. For example, my hand can't go through this, but water, which is an example of liquid, my hand can go through it. I can pour it. And liquids, they don't have definite shape. If I have a container like this, and I pour water on it, the water will bend to take that shape because it doesn't have a definite shape. While in gases, the force of attraction between them is so loose, the particles are not together at all. For example, smoke, you try to use your hands to cut them. So they exhibit random motion. The motion is zigzag. You can even compress gases. Okay? So these are different states of matter. For example, water can exist in 3 states. If you buy a pure water or rainwater, that is liquid, right? You fetch a little, you put in your freezer. Then you turn it on. If your freezer is very good, not those ones that take 1 year to block, within some minutes, it gets frozen, which means the solid is now, the liquid state has now changed to solid. You now say, wow, it has frozen. This means change of matter from liquid to solid is called freezing. Now, you take the rainwater, you say, everywhere is cold. I need hot water to bathe. You put the water in your kettle, then you stay in your room, you are watching TV. Messi, Ronaldo, or what else? Okay, Davido can sing. Okay, or whiskey, or you are arguing with your friend, or watching cartoon, or doing whatever you like. Okay, now, or you are watching Kim Shu, like Kim Shu. So before you get to the kitchen, you discover that the water, it has evaporated. That where is the water? So most of the parts has turned to gas. In that case, you see boiling. As it boils, or it begins to evaporate. So if you are lucky to find small, you notice gases coming from it. It has evaporated. Now from that gas, you put your hand on top of the kettle. That heat, that smoke, gas going off. Put your hand for some minutes, turn it. You notice that it begins to condense. It becomes liquid again. Your hand gets wet. Wow. So from liquid to gases, that is evaporation. And from gas back to liquid, you say it has condensed. That is condensation. Now, this your ice block. You say, no, this water is too block. I can't take this. You keep it. After some minutes or hours, you come back, say, it has melted though. So matter has changed from solid to liquid, melting. Even rubber, plastic, you heat them, you see they begin to melt. So it has melted. So the change of state from solid to liquid is called melting. Now, in some cases, you see a solid like this. In the case of water, as it begins to wet, you see it changes to liquid. From there you can boil, it goes to gas, which is from solid to gas. But in some cases, matter will change from solid to gas, disappears without passing through the liquid state. You just keep it here, it changes to gas. Your clothes will not be wet. That is what we call sublimation. From solid to gas directly without passing through the liquid state. Examples of substances that sublime are ammonium chloride and camphor. You put camphor in your clothes, they will all get finished, but your clothes won't get wet or stained. That's what we call sublimation. While from gases to liquid directly is called resublimation or deposition. Still talking about substances, a substance can be an element, compound, or mixture. element, compound, or mixture. An element is a substance that cannot be split or broken down into simpler form. Okay? An example of elements are aluminium, tin, hydrogen, oxygen. They have their symbol. Talking about elements in chemistry, you'll be required to know the first 20 elements, which are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. If you are going forward, scandium, titanium, arsen, and you go. Okay? So these are elements. And these elements, they have their symbols and they have their atomic number. For example, the first element is hydrogen. So the atomic number of hydrogen is 1. The next one is helium. So the number is 2. So those numbers, they are referred to as the number of proton. Because elements, they have proton, neutron, and electron. The proton is positively charged. The electron is negatively charged, while the neutron is neutral. So if you take this to be an atom, the neutron, proton and neutron, P plus N, they are inside the nucleus, while the electron revolve around. So the charge of the electron, the number of electrons is equal to the number of protons. Charge of electrons is equal to that of proton, but opposite. This is why there is neutrality in the atom. So the number of proton makes up the atomic number. Hydrogen has 1 proton, so the atomic number of hydrogen is 1. Hydrogen, helium, lithium, beryllium, boron, and carbon. Carbon has atomic number of 6, which means the number of proton in carbon is 6. Now there is mass, how heavy an atom is. Like I told you, mass is the quantity of matter in a body. The mass of any atom is the sum of the proton and neutron. Proton and neutron, they make up the mass of the atom. And for a neutral atom, for example, if I say carbon C without plus or minus or charge on top, it means it is a neutral atom. So when an atom is neutral, the number of proton is equals the number of electron for any neutral atom. So the atomic number is the same thing as the number of electron when the atom is neutral, when there is no plus or minus on top. Having explained all this, we go to compound. Compound is a substance that contains 2 or more elements combined chemically. I told you that carbon is a compound, and I mentioned sodium, I mentioned chlorine, I mentioned hydrogen. Now, if hydrogen reacts with chlorine chemically, they form HCl, or they can form hydrochloric acid. A new substance is formed. This is what we call compound. This one, it contains 2 elements, HCl, chemically combined. So the property of HCl is different from the property of hydrogen and it's different from the property of chlorine. So given this NaOH, this contains 3 elements combined chemically. This is sodium hydroxide. Okay? Now, if you have NaCl, sodium and chlorine, you have sodium chloride, that is salt. This is a compound, or H2SO4. Tetraoxosulfate 6 acid. These are compounds. While on the other hand, when 2 or more elements or substances are combined physically without chemical reaction, we call them mixture. Air is a mixture. Hydrogen, oxygen, noble gases, and a lot of mixture. Blood is a mixture. Okay? So sand and garri, they are mixture. They are separated physically, so you can separate mixtures, unlike compound. This is why separation of mixture is something you should also know in chemistry. When things are mixed, how do you separate them? Examples of separation technique are filtration, evaporation, sieving, decantation, chromatography, crystallization. Crystallization is for drugs because purity is required. While distillation works based on the principle of a boiling point. If the boiling points are far apart, you use simple distillation. That should be under an alcohol, production of local gin. While fractional distillation is for crude oil, a lot of components having closer boiling point. So we shall get to questions like that later. So a subscription will be very, very important. Now, back to the question. The change of state of a substance from solid to liquid is known as, like I already explained, from solid to liquid is melting. And I said from liquid to gas is evaporation. Salt in water, salt dissolves in water. So that is dissolution. While sublimation, from solid to gas without passing through the liquid state. And I gave you an example, ammonium chloride. I also said camphor, the Sublime. We've answered the first question. Let's see the second question. The graph represents dash. Remember, we said the substance or matter can be an element, compound or mixture. It can exist as solid, liquid or gases. Now, when a matter exists in the gaseous state or as a gas, what are the laws that gas follow? Before then, we will soon be dealing with ideal gases and real gases. Look at this curve. What is taking place? We have temperature, this in degrees Celsius. We have volume, and we have minus 273. That is the lowest possible temperature, minus 273. So volume, temperature. You see volume, as volume go up, temperature also increases. This graph relates volume and temperature. And which of these law relates volume and temperature? Let's see. It says Graham's law. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its density. The rate of diffusion of a gas is inversely proportional to the square root of its density. While Boyle's law states that the volume of a fixed mass of gas or the volume of a given mass of gas is inversely proportional to its pressure, provided the temperature is constant. Which means anytime you are given calculations under gas laws and you are told that the temperature is constant, that means it's likely to be Boyle's law. And from here, we don't solve with proportionality symbol in mathematics. You change proportionality to equality, and doing that, you introduce a constant. Even in mathematics under variation, anytime you see this guy, change this to equals to k. This is what you use to solve. Therefore, volume is equals k times 1 over p. Boyle's law. How about we are given two gases? For two gases, the first gas will be V1, P1. Volume of the first gas, pressure of the first gas. The second gas will be V2 is equals K over P2. From this, K is equals V1, P1, right? From this, K is equals V2, P2 when you cross multiply. This means K is equals K. Therefore, P1, V1 is equals P2, V2. P1, V1 is equals P2, V2. So this is a very useful formula for solving under Boyle's law. They will say find the pressure if the volume changes to so cm cube or dm cube. So you just make any of them subject formula, you solve. So this qualifies to solve almost all the questions you see, calculations you see under Boyle's law. Now, Boyle's law does not relate volume and temperature. It relates volume and pressure. Temperature is constant. It doesn't change. We don't care. Before I explain Charles' law, in gas law calculations, anytime you are given temperature in degrees Celsius, always change to Kelvin. We don't solve in degrees Celsius. So if I say 20 degrees Celsius, change it to Kelvin by saying plus 273. So that will give you 70, 80, 90, so that's 293 Kelvin. So always change to Kelvin. Don't solve in degrees, so long gas law is concerned. Now, Charles' law states that, okay, let me write them down. V is inversely proportional to pressure. Charles' law states that the volume of a given mass of gas is directly proportional to its temperature. to its absolute temperature, provided pressure is equals constant. So if we keep pressure constant, the volume of any given mass of gas is directly proportional to its temperature. This means volume is equals kT. So K is equals volume over T. And if you are given two gases, the first one V1, the second one T1, the first one T1. For the second gas, V2, T2. So constant is equals constant, therefore V1 over T1 is equals V2 over T2. So this is very important for calculations under Charles law. They will say a gas of 200 cm cube at 20 degrees Celsius has dash 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 dash. Calculate the volume if the temperature is increased to 30 degrees Celsius. So you simply say the new volume is V2. So V2 is equals cross multiplying V1 T2 over T1. So the temperature 20 degrees Celsius plus 273. That is T1. T2, it increased to 30 degrees Celsius. So that is 30 plus 273. So this is your T2, T1. You substitute, you solve. You are good to go. You see questions under gas law. I think in this part 1. Yes. You see. So this is Charles law. Now what does this graph explain? As volume increases, temperature increases. That is direct proportionality. For Charles law, as volume increases, pressure reduces. As pressure increases, volume drops. But in this case, it's directly proportional. And here is degrees Celsius. We can also represent Charles law as something like this. It starts from here. Here is volume, here is temperature in Kelvin. So it starts from here directly. The last law, Avogadro's law. Avogadro's law states that equal volume of gases at the same temperature and pressure, they will contain the same number of molecules. So number of mole is proportional to volume. Let's look at something. PV equals nRT. This is how it came about. Looking at volume is inversely proportional to pressure. Volume is directly proportional to temperature. Volume is directly proportional to number of mole. So let's pick out volume. So proportional to temperature and to number of mole is direct proportionality. So NT. To pressure, it is inverse proportionality. So P. And changing this to equality, we have V is equals, the constant is RO, the general gas constant, nRT over P. So cross multiplying, PV is equals nRT. It is simply the ideal gas law. This is the ideal gas constant, temperature, number of mole, volume, and pressure. So the correct option is option C. This represents Charles law. I was able to explain that matter can exist as solid, liquid, and gases. And substances or matter can change from solid directly to gases without passing through the liquid state. This is called sublimation. And substances can change from gases directly to solid without passing through the liquid state. This is called deposition. Example of deposition is water vapor in air. Water vapor under a very low temperature can change to ice directly. This is why in cold region, you look at your window, you see block, it appears. So not liquid or water coming first before changing to block. That is deposition. While for sublimation, ammonium chloride, camphor, I think methanol, and some substances, they change directly from solid, they just go to gas. You won't see them too wet, anything. I was able to explain all that. Let's look at this set of questions. The first one says, according to the kinetic theory, an increase in temperature causes the kinetic energy of particles to dash. Gases are in a state of constant random motion. They move in random manner, zigzag manner, and they collide with one another and the containers, the containing vessel. So According to this theory, an increase in temperature causes the kinetic energy of particles to dash. A increase, B decrease, C remain constant, and D be zero. As temperature increases, the particles they get more energy and they begin to move. So the more the movement, the more the energy. So increase in temperature causes the kinetic energy of particles to increase. And energy can either be kinetic or potential. Kinetic energy is the energy a body possesses due to motion. So as you are moving or as a body moves, the energy it possesses is kinetic energy. While potential energy is the energy possessed by a body due to its position or due to its height. Meaning kinetic energy Ke is equals half mv square. So the mass of the body times the square of the velocity divided by 2 is the kinetic energy of any body. While potential energy Pe is equals mgh. The mass of a body times acceleration due to gravity times height. Because when you talk about height, gravity has to act. It is a force that brings all objects towards the earth. So this is it on this question. Now look at this. Which of the following could not be an alkane? And you can see the option. What is an alkane? I'm talking about alkane. Organic chemistry comes to mind. Organic chemistry is the study of carbon and its compound, excluding the oxides, sulfides, and the carbonates of carbon. That is organic chemistry, carbon and its compound. Now, the compound of carbon alone, carbon, is more than the compound of every other element combined. Carbon form a whole lot of compounds. And why? This is as a result of catenation and hybridization. Catenation is the ability of carbon to combine with many other elements to form single bond or double bond. Carbon forms single bond, double and triple bond. So that is catenation, and it's one of the reasons carbon form a lot of compounds. The second one is hybridization, mixing of orbitals to form a new one entirely or an equivalent orbitat. That makes carbon tetravalent. So when you are given carbon, carbon can carry 4 electrons. That is tetravalency. So this is the reason we have a lot of organic compounds. Now look at something. Homologous series. Homologous series is arrangement of different compounds as a result of based on their behaviors. So let's treat the alkane, alkene, and alkynes homologous series. These are hydrocarbons. It should be alkanes, alkenes, and alkynes. Now, apart from carbon, oxygen can catenate. Oxygen can form double bond. Sulfur can also catenate. But carbon is unique on that. Given alkane, alkenes, and alkynes, they are hydrocarbons, and hydrocarbons are compounds formed by a combination of carbon and hydrogen only. So if you have something like this, see, hydrogen, 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 hydrogen. This means 1 carbon, 4 hydrogen, CH4. This is methane. It is a hydrocarbon, and this is the most abundant constituent of natural gas. Now, the alkanes, alkenes, and alkynes, or homologous series, they have general formulas. Each series have their own general formulas. They have unique properties and they differ from each other by a CH2 group. The general formula for alkanes, hybridization, hybridization, and its hybridization, sp3, sp2, and sp. The general formulas for alkane is CnH2n plus 2. This is the general formula for the alkanes homologous series. Look at the difference, A, E, Y. Meanwhile, for the alkenes, this is the general formula CnH2n. While for the alkynes, The general formula is CnH2n minus 2. I will show you how to use these general formulas. Before then, a general name for alkanes or common name is paraffin. Alkanes are paraffins. Alkenes are olefins. While alkynes are also called acetylene or acetylene. Say acetylene gases. From this general formula of alkenes and alkynes, hydrocarbon, if N is 2, let's say we have 2 carbon, the alkane will be C2H. 2N is 2 times 2, 4, plus 2, 6, H6. So this will be the alkane formed. While if C is 2, the alkene will be C2H2N, 2 times 2, 4, H4. This will be C2H, 2 times 2 is 4, minus 2 is 2H2. So this is an alkane, alkyne, where carbon is 2, and carbon is 2. How do we draw this? It means 2 carbon, 6 hydrogen. 1, 2, 3, 4, 5, 6. What does this mean? This means 2 carbons, 4 hydrogen. So that should be 1 carbon, second carbon, 1, 2, 3, 4. Now look at this. We have 2 carbons, 4 hydrogen. But remember, I told you that carbon is tetravalent, meaning it can carry maximum of 4 electrons. Look at this carbon. It has formed 3 bonds. 1, 2, 3. This one formed 1, 2, 3. It's not complete. So since we have 2 hydrogen, 4 hydrogen and 2 carbon, it means there should be a double bond here, so that the bonding will complete 1, 2, 3, 4, 1, 2, 3, 4. So the configuration is okay. What does that tell you? Alkenes are unsaturated. Unsaturated hydrocarbons. This is saturated. So it has double carbon to carbon bond. While for this alkyne, it means 2 carbon C2H2. If we have 2 carbon and 2 hydrogen, carbon here has formed 2 bonds. Here has formed just 2 bonds. Remaining how many? This one is remaining 2 to complete. This one is remaining 2 to complete. So this gives you, if we have 2 bonds here, it's still not complete. If you have 3 here, so this has formed 1, 2, 3, 4, 1, 2, 3, 4. So it's complete. So alkynes are unsaturated hydrocarbon with triple carbon to carbon bond. They have triple bond. So this is what makes alkynes, alkenes, and alkanes. Now the simplest alkane is CH4, methane, CH4. While alkene can never have 1 carbon because there must be that double bond. So 1 carbon cannot bond itself 2 times. While this cannot have 1 carbon. So this is ethane, like ANE. This is ethene or ethene, ENE. This is ethyne or ethyne, alkyne. Now if we have 3 carbon here, C3, it will be propane, propane. While 3 carbon here, propene, propene. 3 carbons here, propane. 4 carbons, butane. So when there is 4 carbon, this will simply be C4H, 2 times 4, 8, plus 2, 10, H10. This is butane. While butane is C4H, N is 4, that's number of carbon, 2 times 4, 8, H8, that is butene. Butane will be C4H, 2 times 4, 8, minus 2, 6, H6. This is butane. 5 carbon, pentane, pentene, pentyne. 6 carbon, hexane, hexene, hexane. 7 heptane, heptene, heptyne. 8 octane, octene, octane. Like that. If you are to draw this C4H10, it is simply 1, 2, 3, 4. So others are hydrogen. So this is alkanes. But for this, there will be a double bond and C4H8. So we have 1, 2, this 4. So 1, 2, 3, 4, 5, 6, 7, 8. So these ones, they are complete. 1, 2, 3, 4 bonds, hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. But this one, 1, 2. So it needs to be complete. This means this won't be here. This will be here. H, H, H. This will be here. So this means 1, 2, 3, 4 bonds. 1, 2, 3, 4. So the double bond will be here. For this C4H6, 1, 2, 3, 4. There must be triple bond. So hydrogen. This one is just one hydrogen. No hydrogen here. Hydrogen here. So from this, these options begin to make sense to you. Which of the following could not be an alkane? How will it begin to make sense to you? How will an alkane with 5 carbon look like? It will simply be C5H. 2 times 5, 10, plus 2, 12, H12. That is alkane with 5 carbon. This is an alkane. Alkane with 4 carbon, how will it look like? C4H10. Alkane with 8 carbons, how will it look like? To be C8H. 2 times 8, 16, plus 2, 18, H18. So this is an alkane. Alkane with 7 carbon, how will it look like? It will be C7H. 2 times 7, 14, plus 2, 16, H16. But that is H14. So it is not an alkane. So what is that? Let's see if it's an alkene. Alkene with 7 carbon will be C7H. 2 times 7 for H40. This is an alkene. Heptane, alkene, heptene, heptane. Alkyne with 7 carbon will be C7H. 2 times 7, 14, minus 2, 12, H12. So that is it on alkene, alkenes, and alkyne. I hope you found this class helpful. So let's take a look at these other 2 questions. Alright, look at this. It says, in the reaction below, S is a dash. When you are given something like this, let's say something, an element, you have, let's say, 200 here, you have 500 here. The number at the bottom is the atomic number. That is the number of proton, which I've already explained. The one at the top is the atomic mass. And mass is proton plus neutron. And for a neutral atom like this, where there is no plus or minus, proton is equals electron. So this means proton is 200, atomic number. The number of proton is 200. The number of electron is 200, neutral atom. So the mass is 500. That means proton plus neutron is equals 500. Neutron is equals 500 minus 200. Since proton is 200, so that will be 300. So these are basic things you should know. And the law of conservation of mass says that in a chemical reaction, matter is not destroyed, or mass is not destroyed, although it can change from one form to another. These are the reactants, and these are the products. The mass of the product should be the same as the mass of the reactants combined, although different products are formed. So mass is conserved. Look at this. This is S we are looking for. We don't know what S is, but let's see. Let's call the atomic number of S A, and let's call the mass of S B. If you do that, it means the mass of N, 14 plus B, should be equal to 17 plus 1, the mass here and the mass here. Right? Since mass cannot be destroyed, the total mass of the reactant should be equal to the mass of the product combined. So this mass plus this mass should be the same thing as this mass plus this mass. This means 14 plus B should be equals 18. B is equals 18 minus 14. Collecting like terms, this is equals 4. So the mass of the element S is 4. Now, the atomic number, total atomic number here should be equal to the total atomic number here. Meaning 7 plus A is the same thing as 8 plus 1. This means 7 plus A is equals 9. A is equals 9 minus 7. A is equals 2. So this element S is 2 here, 4 here. It is an element with number of proton 2. Since it is neutral, it is an element with number of electron 2. If the number of proton is 2, it means the atomic number is 2. Which element has atomic number of 2? Hydrogen, helium. So helium has atomic number of 2, mass number of 4. So S is a helium atom. So let's look at the options. Lithium atom, neutral atom, helium, deuterium. Deuterium is actually an isotope of hydrogen. So the correct option is helium. This is a helium. We've answered that question. In the reaction below, respectively, S and Y respectively are, we apply the same principle. 234. This is actually a protatinum atom. Protatinum. But that should not be your problem. You don't need to know the element. So thorium, protactinium, and this is a beta particle. What is beta particle? Beta particle is simply an electron, 0 mass, negative charge, minus 1 under. So this is the same thing as this. And alpha, beta, and gamma rays, they are as a result of radioactivity. Radioactivity. Radioactivity is the spontaneous disintegration of the nucleus of an atom to release radiation. Heavy atoms, they get unstable and they disintegrate. Remember from Dalton's atomic theory, he says atom cannot be created or destroyed. No, atoms can be destroyed. That is in artificial radioactivity. Dalton also says that atom is the smallest particle of a substance. Later, we discover that atom is not the smallest particle. We have subatomic particles, which are proton, neutron, and electron. Proton is positively charged, neutron is neutral, and electron is negatively charged, which revolve around the atom. And we learned that the mass of the atom is as a result of the proton and neutron. They contribute more to the mass. We also learned that even one of those protons, they have smaller form. Now, radioactivity, spontaneous disintegration. An atom disintegrates to form particles like alpha particles, beta particles, and gamma rays. Gamma rays. These are particles. Alpha particle is simply a helium nuclei. He42. A helium nuclei, that is alpha particles. While beta particles are fast moving electrons. Gamma, these are rays being produced. So in terms of this radiation, gamma is the most powerful, followed by beta, followed by alpha. The alpha radiation can be stopped by a piece of paper, while beta radiation can be stopped by aluminium foil. Gamma rays can be stopped by only lead block, which means it can penetrate bone, penetrate most heavy stuff. It's very powerful. We also have X-ray. This is another ray. This is used for taking photographs of bones and skeletal structures. So that is an X-ray for you. Now, having these particles, they say, what is this? Thorium went through radioactivity, disintegration. This equation of reaction can be rewritten as 234 thorium 90 SpA Y plus electron, 0 minus 1, because that is beta particle. If you agree with this, just like what we did earlier, 234 is equals S plus 0. So S is equals 234. This means protactinium has a mass of 234. For here 90 should be equals Y minus 1. So Y minus 1, or Y plus minus 1 rather, because this should be equals this plus this, and Y plus minus 1 is Y minus 1. So 90 is equals Y minus 1. Y is equals 90 plus 1. Y is equals 91. Now let's know what is S and Y. S is the atomic mass, and we've solved it to be 234. Y is the atomic number, 91. So it is simply 234 and 91 respectively. So this is the correct option. So I hope you've benefited from this, and I hope you've learned something new. If yes, let's look at the next set of questions. This says, which of the following can be represented with a chemical formula? I explained that a substance can either be an element, compound, or mixture. And I also explained that elements are represented with symbols. I listed the first 20 elements. Meanwhile, compounds are represented with formula, where I said sodium chloride is NaCl, hydrogen chloride is HCl. I gave some examples of compounds. Meanwhile, mixtures contain two or more substances or elements physically combined that are not represented by chemical formulas. So for formula to come into play, it means we must be talking about compounds. This question therefore means, which of the following pair are compounds? Air and bronze. Air is a mixture and bronze is a mixture. Option B says bronze and sodium chloride. This is a mixture. Sodium chloride is a compound. Although this can be represented with a chemical formula, this cannot. So this option is not correct. While option D says copper and sodium chloride. Copper is an element, so it's represented by a symbol Cu. Sodium chloride is a compound, so the pair does not make the complete sense. While option C says caustic soda and washing soda. These are common names for compounds. Caustic soda is simply sodium hydroxide. Washing soda is Na2CO3. So these are .10H2O, Na2CO3, .10H2O, washing soda and soda ash. So these are compounds, and they can be represented by formulas NaOH and Na2CO3. And the next question says, a physical change is dash. In chemistry, we have two types of changes: physical changes and chemical changes. In chemical changes, a new substance is formed. For example, fermentation of sugar, it changes to ethanol, which is alcohol. A new substance is formed and it cannot be reversed. Rusting of iron is a chemical change. It can't be reversed. Or burning of paper. It has happened, it has happened. You can't change it. While in physical changes, new substances are not formed and it can be reversed, which is dissolution of sugar in water. Sugar dissolves in water, then you can use a separation technique to get your sugar back, either by evaporation or any method best known to you, or if you wish to filter later. So an example of physical change is dissolution of sugar in water. And this says the pressure of 100 cm³ of oxygen at 350 degrees Celsius is 750 millimeter mercury. What will be the volume of the gas if the pressure is reduced to 100 millimeter mercury without changing the temperature? Wow, we've gotten a keyword: without changing the temperature. This means temperature is constant. And which of the gas law works when temperature is constant? That is Boyle's law, which states that volume is inversely proportional to pressure so long temperature is constant. And from here, we're able to derive P1 V1 is equals P2 V2 for two gases. Now we are told that the pressure of 100 cm³ of oxygen at 350 degrees Celsius is 750 millimeter mercury. So P1, the first pressure, is 750 millimeter mercury. And the volume, as we can see, 100 cm³ of oxygen. We are told that what will be the volume of the gas if the pressure is reduced to 100 millimeter mercury. So pressure, the second pressure or the new pressure, P2, is equals 100 millimeter mercury, Hg. What will be the new volume? That means find V2. From here, V2 is simply P1 V1 over P2. And that is 750 times 100 over P2 is also 100. So this is 7 millimeter mercury, and volume cm³. Millimeter mercury cancels millimeter mercury, 100 cancels 100, so we are left with 750 cm³. This is the volume. The temperature remains constant. Now let's look at this. It says at 27 degrees Celsius, 300 cm³ of a gas sample exerts a pressure of 220 millimeter mercury. How many moles are present in the gas sample? The Avogadro number, or the number of molecules, is 6.02 times 10 raised to the power of 23. And this is the general gas constant, 0.08219. Look at 5 things to learn from this question or to apply when you see questions like this. 1, we are given the general gas constant. This means we are dealing with the ideal gas. So we need to introduce the ideal gas equation, which says PV is equals nRT. Now, number 2, look at the ideal gas constant. You see ATM, which means the pressure is in ATM. So we convert 220 millimeter mercury to ATM. 720 millimeter mercury to ATM, which means the pressure is equal 720 divided by 760. This is conversion from millimeter mercury to ATM. You divide by 760 to give you in ATM. You see that dm³, the volume should be in dm³. The volume we are given is in cm³, 300 cm³. So we convert to dm³. Converting volume from cm³ to dm³, we divide by 1000. So V is equals 300 over 1000. This will give you 0.3 dm³. Now, mole, which means we need to find the number of mole. It's not given here. Temperature should be in Kelvin, as you can see, per Kelvin. We are given 27 degrees Celsius. And I told you to convert temperature from degrees Celsius to Kelvin, you add 273. So this will give you 300 Kelvin. And we have R. So number of mole is what we are looking for. Number of mole, N, is PV over RT. That is P, which is 720 over 760, times V, which is 0.3, over R, 0.08219, times temperature, which is 300. This will give you 0.0115. That is the number of mole. After getting this, you do something like this. For any gas, 1 mole contains 6.02 times 10 to the power of 23. This is what 1 mole contains. If 1 mole contains this implies that 0.0115 moles will contain S molecules. 0.0115 mole will give you S. S is simply equals 0.0115 times 6.02 times 10 to the power of 23 over 1. And that should give you 6.9 times 10 to the power of 21. So this is the number of molecules that 0.0115 mole will give you. Wow! This brings us to the end of the part 1, likely chemistry questions. Watch out for part 2 because more questions will come in, more explanations, and by then I'll have more energy to proceed. So subscribe to this channel so you don't miss out any of my guides. Thank you. Have a wonderful day.